Take a look at these pictures. They don't look exactly the same, do they? We have a circle, a rectangle, and a group of stars. But believe it or not, they can all represent the same fraction, 1/2. So how can one fraction have so many different looks? That's what we're going to investigate today. By the end of this lesson, you'll be able to recognize and represent fractions in several different ways. We'll use shapes, groups of objects, number lines, and fraction notation. The models may look different, but you'll learn how to uncover the fraction hiding inside each one. There are several ways to show a fraction. We can shade part of a shape. That's called an area model. We can select objects from a group. That's called a set model. We can locate a fraction on a number line. And of course, we can write the fraction using numbers and a fraction bar. Let's explore each representation. Let's begin with an area model. This rectangle represents one whole. The whole has been divided into 4 equal parts. Notice that I said equal parts. That's important. If the parts aren't equal, the model cannot represent fourths. 3 of the 4 equal parts are shaded. So the fraction represented by this model is 3/4. Before we move on, let's check something very important. Both rectangles have 4 sections, but only one is a correct fraction model. Why? Because a fraction describes equal parts of a whole. The sections in this rectangle are equal, so each section represents 1/4. The sections in the other rectangle are different sizes. That means we cannot call each section 1/4. When you examine an area model, always ask, are the parts equal? Here's something interesting. A fraction doesn't belong to only one kind of shape. We can shade 2/4 of a circle, 2/4 of a rectangle, or 2/4 of a square. The shapes are different, but each whole is divided into 4 equal parts, and 2 parts are shaded. So every model represents 2/4. Fractions can also describe part of a group. This is called a set model. Here, we have 8 apples altogether. 3 of the apples are selected. The denominator tells us the total number of objects in the group, so our denominator is 8. The numerator tells us how many objects are selected, so our numerator is 3. 3 out of 8 apples are selected. The fraction is 3/8. Let's compare an area model and a set model. In the area model, one whole rectangle is divided into 5 equal parts, and 2 parts are shaded. In the set model, there are 5 separate balloons, and 2 are selected. One model shows part of a single whole. The other shows part of a group. Even though they work differently, both models represent 2/5. Fractions are also numbers, so they have exact positions on a number line. This number line begins at 0 and ends at one whole. To show fourths, we divide the distance from 0 to 1 into 4 equal intervals. Now we count 3 intervals from 0. 1/4, 2/4, 3/4. That means this point represents 3/4. Number lines can be a little tricky, so here's an important reminder. To identify the denominator, count the equal spaces between 0 and 1. Don't count the tick marks. This number line has 4 tick marks, but it has only 3 equal spaces. That means the whole is divided into thirds, not fourths. Say it with me. Count the spaces, not the marks. Now let's connect a visual model to fraction notation. First, count the shaded parts. 4 parts are shaded, so 4 is the numerator. Next, count all the equal parts in the whole. There are 6 altogether, so 6 is the denominator. Place the numerator above the fraction bar and the denominator below it. The model represents 4/6. Let's represent 2/3 in 3 different ways. For the area model, divide one whole into 3 equal parts and shade 2. For the set model, use a group of 3 objects and select 2. For the number line, divide the distance from 0 to 1 into 3 equal intervals. Then move 2 intervals from 0. We use these fraction representations in real life too. A sandwich cut into equal pieces is like an area model. 5 eggs out of a group of 6 is like a set model. The markings on a measuring cup work like a number line. Once you understand the models, you'll start noticing fractions everywhere. Time for a fraction detective challenge. 3 of these representations show the same fraction. One does not belong. Pause the video and study each model carefully. Models A, B, and C all represent 3/4. Model D represents 3/5 because the whole number line is divided into 5 equal intervals. So model D does not belong. You did an excellent job exploring different fraction representations. An area model shows part of one whole. A set model shows selected objects from a group. A number line shows a fraction's exact position between whole numbers. Fraction notation uses a numerator and denominator to record the fraction. The models may look different, but they can still represent the same amount. Here's your final challenge. Can you represent 5/8 in 3 different ways? Create an area model, a set model, and a number line model. Remember, every model should show 5 out of 8 equal parts, objects or intervals. You can draw your models on paper and tell me in the comments which one was easiest for you. If this lesson helped you, give the video a like and subscribe to OLS Math Academy. I'll see you in lesson 3, where we'll explore equivalent fractions and discover how different fractions can represent the same amount. Keep practicing. You're doing great.